Okay, so in this video lecture, we're going to cover compound statements and complex truth tables. So essentially, we're going to be building up from what we've already studied before. We're going to be making more complicated problems, but essentially the basics are just going to be slightly expanded. So we're going to take atoms, combine them together, and evaluate more complicated sentences. Okay, so to start off, we're going to work on compound statements. So just again, pulling from the book. Let's determine the truth value of the following statements. 3 plus 2 equals 7, and 4 plus 4 equals 8. Two plus 1 equals 3, or 7 plus 2 equals 9. Four times 4 is 16, or 4 is greater than 7. Okay, so this first sentence, because there's an and, the only way that the whole statement can be true is if both parts of it are true. So this is true, right? But this is false, right? 3 plus 2 is 5. 5 does not equal 7. Therefore, this is false. How about this one? We see an or, and so we need at least one of them to be true. Okay, so they're both true. 2 plus 1 is 3. 7 plus 2 is 9. And, and therefore, this whole thing is true. Just keep in mind that just because both of them are true does not mean that this is false. It's not the case that we need exactly one to be true. Okay, so what about this one? So 4 times 4 is 16, or 4 is greater than 7. Well, obviously 4 is not greater than 7 because 4 is smaller than 7. But because 4 times 4 is 16, the whole thing is true. Okay. How about this example? Paris is in France. Or 2 plus 1 is 6. Well, because Paris is in France, right? Because Paris is in France, this whole statement is true, right? The statement Paris is in France, or 2 plus 1 equals 6 is true, even though 2 plus 1 does not equal 6. So the whole thing is true, and I think that we've probably exhausted that idea. I think that it's pretty clear. So that's pretty much all I want to say about compound statements. Now we're going to move on to more complicated truth tables. Okay, so let's say we had to evaluate the times in which the following statement is true or false. So in other words, I ask you, construct a truth table for P and not Q. Sorry, not P and not Q. So how can we do this? Well, there's a few different methods. I'm going to demonstrate the one that I use, and if you want to do it another way, you can look in the book or online, but for the purpose of just doing it one way, keeping a consistent style, I'm only going to present one strategy. Okay, so we're going to make our table, and let's see. So okay, so here's our P, our Q, and our final answer is going to be not P and not Q. Really, I should pause after saying the first not, because it's not P and not Q, right? Where is that not going, right? It's around the whole thing. Okay, so I want to get to this as my final column, and so what I gotta do is work backward, right? So this whole thing is true or false depending on what's on the inside. So because P and not Q is on the inside, I'm going to go ahead and I'm going to write that right here, right? And now I can look at this and I can say, okay, what makes up P and not Q? Well, there's P. Hey, there's already a P over here, right? And then not Q. So we got to make a column for not Q, and I'm going to do that right here. And that's basically it. Now, some of you are going to skip ahead to this, skipping this step. I would say go ahead and show all your work at the very beginning. Get that practice in. Okay, so because I have two variables, I'm going to have 4 rows. Okay, and in general, the number of rows that you need is going to be 2 to the n, where n is the number of letters, atomic variables, right? P, Q, R, S, and so on. And the reason you get 2 to the n for the number of rows is because there are 2 options that the variable could take, true or false. And so if you had, let's say, 4 rows already, let's say you added a new letter to that, right? So if you add a new letter to your formula, then you have to consider all the cases when that letter is true and all the cases when it's false. And so you're effectively doubling the previous number of cases, right? So basically, in a nutshell, if that didn't make sense, you can just memorize, right? If I have n variables, I need 2 to the n rows. Okay, so let's go ahead and fill this in. So a P can be true, Q can be true, P can be true, Q can be false, P can be false, Q can be true, and they could both be false. So also, just as a word of advice, I think it's really important to have some sort of order when you do this. Sometimes I see students do stuff like first they have true and false, then they have false and false, then they have true and true, and then they have true and false. You can do it, strictly speaking, you can do it however you want, but you're likely to forget something or copy something over wrong. I would just say develop the habit of just writing it in this exact order. That way, it just keeps things simple. Okay, so as before, I'm going to use green as my intermediate step. So if Q is true, then not Q is false. This will be true. This will be false. This will be true. Okay, so now I'm going to take the value of P together with the value for not Q, and as long as there's at least one false popping up, the whole thing is false. And if they're both true, the whole thing is true. Okay, so here there's a false, so this is false. Here there's a true, and there's a true there, so this whole thing is true. Two falses, so that is false. I only need one false, actually. And here we have a false, so this is false. Again, that's from, that is from the column P, and P is in that formula. That's where I got that. Okay, so for the final step, I'm going to use blue, and this is, I'm just going to take whatever value is in this past column, and I'm just going to take the negation of it. So false becomes true, true becomes false, false becomes true, and false becomes true. Okay, so that's basically it. I'm going to do one more example like this. Okay, so in this case, this is from page 7 of your book. So here we have the statement P and Q or R. Okay, and we have 3 variables, so there's going to be 2 to the 3rd number of rows. That's just 8. So there's going to be 8 rows, and based on the complexity of this, that's how many columns we're going to use. So we got to be careful, make sure we can fit everything. I like to start off building my columns before I build my rows, because you just work backward. Start with the only thing you know and work backward. Okay, so the simpler parts of this are P and Q or R. Now P is a basic variable, so I'm going to go ahead and write it over here. And Q or R, that's a little more complicated, so I'm going to put it right here. Okay. Now looking at this, it consists of Q and R, so I'm going to go ahead and write those right here. So Q and R. Great. Now, because there are 3 variables, again, we're going to need 2 to the 3 number of rows, which is 8. So we need 8 rows. So that's 2, 3, 4, 5, 6, and 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Okay, so let's see. So we're going to go through this systematically. P can be true, Q can be true, R can be true, right? And now I'm going to hold the first two fixed, and I'm going to change R. This is kind of like a speedometer, you know? You don't change the... You change first to the right, and then you move towards the middle, and as they flip over, new things appear. Okay. So now that's false, and so this is like the speedometer flips over to true, and this will become true, and this will become false. Okay, so false, true, false, 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 true, and then we finish with false, false, false. Okay, so as you can see, because the number of combinations gets big pretty quickly, you can see why I try to stress having some sort of general technique, keeping it organized, right? So part of the reason I switch colors is because that also helps you stay organized. So I would personally recommend when you do this on your own, maybe use different colors, just when you work it out on paper. Okay, so for this, we're going to go through and we're going to only look at Q and R, forget about P, and if at least one of these values is true, Q or R is true. So this is going to be true because R is true. This is going to be true because Q is true. This is going to be true because R is true. Here, neither is true, so this is false. At least one of them is true here, so the whole thing is true. One of them is true, so this is true. This is true, and this is false. Okay, so now we don't really need Q or R, but we need Q or R, right? for this last bit. So I'm gonna use a different color, and we're just gonna look at these two. We're just gonna look at these two. Okay, so because there's that and symbol, right? We need both things to be true for the whole thing to be true. Okay, so T and T, so true. True and true, so true. True and true, true. False, so the whole thing is false. False over here, so the whole thing is false. And then, you can look ahead and you see, okay, false, false, false. Okay. Okay, so there you have it. Basically, that's it. It's true almost half the time. Okay, so let's clear that out. Okay, so here are some more examples. Okay, so previously we talked about but and how but is really and. So we're going to go through some plain English examples. This is problem 113. So the question is, or sorry, the statement is P is Mark is rich. And Q is, Mark is happy. Okay, and we're asked to convert the following statements into symbolic form. Okay, so Mark is poor, but happy. And then there are some other examples. We'll get to those in a little bit. So, okay, the first thing we can do, right, looking at the sentence, we see but, and we can right away, we can just rewrite that, right? That's and. Okay, and also, just based on the way our language works, if Mark is poor and happy, right? If this is a true statement, then it is also true that Mark is poor and Mark is happy, right? So this just gets back to that discussion I gave last lecture, maybe the one before, about how and works, right? So P and Q is true just in case P is true and Q is true. So because I have this, right, I can basically push the Mark is statement, push it through, right? And now we almost have what we've started with, right? So Mark is poor. Okay, so here's rich and here's poor. And so those are basically opposites. And so one way you can think of this is you can think of this is Mark is not rich, right? But that doesn't help you either because not rich, we don't really, we don't necessarily have a way to write that in symbolic form. So another way of understanding it, just because of how language works, you can think of it as saying, it is not the case that, right? So it is not the case that Mark is rich. And then you probably want to put a comma and Mark is happy. Right? And the reason we put this comma here, I guess I should have put it here too. The reason we do this is because if I say it is not the case that, right? If I say that at the beginning, right, you might think that it's supposed to be read like that. It is not the case that he is both rich and happy, right? So at least one of those is false. That's how you would read that. So you need to understand that the statement, it is not the case that, it's only applying to Mark is rich. Okay, so, well, what can we extract from this? Okay, well, Mark is rich is P. Mark is happy is Q. Here we have an and here this it is not the case that is a negation, but again, it's only applied to Mark is rich. So this is, at the end of the day, it's just not P and Q, which, again, I just want to stress this. This is not the same thing as not P and Q. Okay, in the next video, we're going to discuss this equation a little further, and we're going to make sense of how the negation distributes through parentheses. Okay, see you there.